I'm Anil Kumar, and here is my answer to the most popular question from my subscribers on derivatives. Most of my students want to use what type of notation should be used when. Now, I've been avoiding this question for a long time, but now I think we are beginning to start with the derivatives, and it's a good point to discuss. You'll find in books four different kinds of notations being used for derivatives. So we call first, which is very popular, is Leibniz notation, where you write dy over dx. Also, we can say dy dx. The second one is prime notation. We call it prime notation or Lagrange's notation, f dash x. Then we have Euler's notation, capital dxy, and Newton's notation, y dot. Now these are not very popular in our syllabus, but they are used in dynamics and other places, right? Newton's notation, dy by dt. Normally in dynamics we use Newton's notation, where y with the dot is used. So we'll basically concentrate on two notations. First one is Leibniz, the second one is Lagrange's, or also known as prime notation, right? So we also, because f dash x, f prime, right? So that is how it gets the other name, prime notation. Now, the main question here is when to use which notation? That's a huge question. As far as my preference goes, to write formulas, we use prime notation or Lagrange's notation. It's very convenient. For example, if I have to write what is the formula for derivative of sum, right? So it is very easy to write. It is f dash plus g dash, right? So it's so simple, correct? Similarly, for difference, it will be difference, and for product, it will be f times g prime, which we'll learn in the next chapter, will be derivative of the first times the second plus first times the derivative of the second. So it's very convenient to write formulas. So my preference is that whenever you write formulas, you should use Lagrange's notation. Very simple, right? But when you're really solving some questions, Leibniz notation is far better, especially as we move forward with chain rule. It is very difficult to understand the solution if you do not use Leibniz notation, correct? So you should get into the practice of using this notation. Howsoever, I'm not saying that you should be using it, but I prefer you to get used to using Leibniz notation right from the very beginning. It will be very helpful to you. That's my suggestion. Now, another way to look into this is which notation to use when. It sometimes depends on the question also. If I have a simple question, let me take one simple question here as f of x equals to, let us say, 3x squared minus 2x plus 1. And I need to find derivative of this function. So very conveniently I can write f dash x is equals to, we'll apply the rules, power rule. So 3 times 2 is 6, so you get 6x minus 2 as our solution, correct? So when you have an equation in the form of function notation, Lagrange's notation is the preferred way of solving. So that comes by default, right? However, if I write a similar equation in the form y equals to, let me take a radical like square root of x, for example, minus let us say 2x cubed. I'm just adding some numbers here with variables, right? So if I have kind of like this, I'll prefer to use Leibniz's notation dy dx, right? So we can write derivative as dy over dx equals to derivative of d dx, that means of 2 square root of x, right? 2 square root of x minus d dx of 2x cubed, right? Now it is constant time the power, so we'll apply the rule. So 2 comes outside, so 2 times d dx of, it may be advisable to write x square root as x to the power of half, right? And here we'll write 2 times d dx of x cube, right? Since it is a constant, I have taken it outside, correct? So the rule with constant, as you know, is if f of x is equals to, let's say, k times g of x, right? Then you could write f dash x as equals to k times g dash x, right? So that is the rule which I'm applying here, correct? Now, since I have to apply the power rule, which you remember, which is kind of f of x equals to x to the power of n, then f dash of x is equals to n times x to the power of n minus 1. You see how convenient it is to write prime notation for the formulas, right? Now, but for solving questions, this is better, right? So let's go ahead. I'm trying to solve this particular equation in steps details so that you get the whole idea of what we're talking about. So it is 2 times derivative of x to the power of half. We'll apply this power rule, n times x to the power n minus 1. So n here is half, so we get half times x to the power of half minus 1, which is minus half, correct? Minus 2 times, again apply the power rule, it will be 3x squared, correct? So it is 3 times x squared. So now we can simplify this a bit. 2 divided by 2 is 1. X to the power of minus half you could write as 1 over square root of x, right? Minus 3 times 2 is 6x squared. So that becomes the derivative of the given function. Do you see that? So these are the steps involved. Well, in the book I've also seen that when we use the prime notation, there also we use ddx in the solution, right? So, but my preference is, as I said, when you're writing formulas, Lagrange's notation is far better. Very convenient to clearly mention or show what the formula is. But when it comes to solving questions, I'll prefer you to use Leibniz notation, right? So that is how you should be doing. In most of my examples, I will skip these steps, right? But this is a good place to give you all the steps. To start with, you should be solving problems in such steps, right? And then derive at the solution. I hope that helps you to understand. We'll take one more example to see which rule should be applied where and how. Thank you and all the best.